So hi everyone and welcome back to the channel. Hookless or hooked? I'm actually going to design my own molds for both and see which one's better. Is there an advantage to hookless outside of just the manufacturing? And is there even a manufacturing benefit from using hookless molds and rims? What do you use? This is hooked. I do have rims that are hookless. We're going to discuss the news at the moment that Veloforte has come back around into the cycling media with Thomas Gendt crashing at the UAE Tour, purportedly blaming that on hookless tyres. But it's not just the pros, it happens to us Freds as well. You've only got to scour Google for about 10 seconds to find a load of Reddit posts, a load of Wait We Knows posts about, you know, tyres blowing off of Zipp wheels, hookless wheels, and there just doesn't seem to be any progress.
Denied.
You got conflicting standards between the ET RTO and the teams. The teams are ignoring the safety guidelines from the ISO, so the international body, and they come out with this weird statement saying, we use, obliged by the UCI, 28mm tyres. Well, first of all, they're not obliged to use 28mm tyres, so I don't know what that's about. On 23 or 25 inner rims. Now, basically, long story short, according to Zipp, that's fine, but according to ISO, that's not fine. So ISO say 29 is the lowest they should go. So there's a lot of finger pointing. This really doesn't need to be happening because we never had this problem before. We never had this problem before. So I'm going to look into the manufacturing process and just see if it's worth, from like a lean manufacturing point of view, is it worth doing this? Because there doesn't seem to be any user benefits. And if there are user benefits touted by the brands, I think it's all just kind of cover-ups for just, you know, leaning out production, being consulted by McKinsey and saving money. So we're going to look at the mold design. We'll look at a vehicle comparison because you get a lot of backward hat Dylans going, oh my God, Pig Torque doesn't know what he's on about. I got hookless and tubeless on my four-wheeler. My F250, that's running 600 horses. When I go four-wheeling, I never pull the tires off. What the hell? This guy doesn't know what he's on about. Like, they probably don't even have like F250s in the UK. You know. Automotive engineering is like an example of lean manufacturing. It's been leaned and leaned and leaned over 100 years. But if there's anything that comes across that safety margin for the users or the occupants, you take a step back. But this is something that's gone a bit too far. This mold is pretty messy. There's about 16 parts here just for a hookless rim. When you look at the mold, you can kind of see why they wanted to do hookless. Now, I went through this process of designing the rim and the mold myself to see if it was actually worth doing the hookless. How much does it benefit the actual manufacturing, the yield, the cost and everything? Well, first of all, it's worth just remembering that the companies that sell rims like Zipp, okay, they use factories to make the carbon rims. Those factories that make the carbon rims, 95% of the time, they don't make the molds in-house. So there's another step there, there's another middleman. The factory then goes to a mold machinist, and this is a factory that just makes steel molds. And in the CAD, this one weighs 140 kilos. It's a serious amount of steel. There's loads of parts, everything has a drawing. So that mold cost is a huge initial chunk of the investment by the brand into releasing a new line of wheels. So we're talking tens of thousands of USDs for the molds. There's just the tooling. So if the tooling can be simplified, that's a huge initial cost saving. Everything's improved, like cash flow, you know, like forecasting becomes a little bit less important if all your offset costs up the front are a bit lower. Let's have a look at, first of all, the hooked rim. This is traditional hook rim. Let's put the mold top back on. If you look at it, first of all, it's just like a big kind of cake, but when you zoom in you can see how many parts are actually in this to be able to get the rim out. I've worked backwards from the rim. So first of all, I just drew the rim. So if I show you my rim, you can see it's 50mm deep. It's really wide, so I made this one like 25mm internal. It's got a hook in there, and that's like the standard hook size that they're all using, and it's got the kind of ET RTO center groove for the tubeless to drop down into, and it's also got the little bump just on the lip there. A really simplified version because I haven't even put any alignment dowels in it. There's no clamping bolts. I haven't drawn the block where the airline goes in. So inside this rim there is a bladder. So this is a cross section of the rim, and inside the rim you can see there's this white bit which is just the bladder. So I'm showing you where the air pressurizes the rim from the outside. Most of the other parts of the rim, sometimes they put a bladder in the bed against the rim bed here, but these areas of the rim where it's solid, where the hook is, are actually just compression molded by the mold being squeezed together. There's no bladder in there because it's not hollow, but I haven't drawn the molding lines and the pipes and everything, so there are actually a few more metal blocks in this mold, and I think this mold is 14 pieces already. What I'm getting at is that it's no wonder why if a manufacturing engineer came in to look at this mold and went, why is this mold in so many pieces? And it's in so many pieces because of the rim hook. Now, if you weren't to do it in such a modular fashion, you wouldn't actually be able to get the rim out, or you wouldn't be able to take the mold pieces apart, because the hook, literally, when everything's set and solid, the hook grabs everything. Right, so this is an absolute mess. This is the exploded view of all the parts of this mold, and that, like I said, is not including the airline block, the fixtures for that or anything, any of the dowels or any of the bolts. And this is how many pieces, at least 14 pieces, you need to make a hooked rim. It's funny because they do it. They've been doing it like this for 10, 15 years. But when, like I said, you are outsourcing that mold production to someone else, their costs go up because of something called tolerance stack up. So not only have you got, you know, a huge amount of steel here, and steel is cheap in China, don't get me wrong, but with so many different parts, you've got much bigger problems with tolerance stack up. So let's say you've got, you know, a thick part that's made up of 4 sections. If your tolerance on each of those sections is 0.1, the total maximum length would be 0.4 bigger. If it's only made out of one part, the tolerance stack up is 0.1. So it's 4 times smaller possibility of like errors stacking up. That's what tolerance stack up is. Making a hooked mold is the tolerance stack up is quite large because it's made up of so many pieces, not just for the thickness. You've got them all cut into 4, so you can actually extract the parts outwards when you demold the part, because you can't just make it in one ring. And tolerance stack up becomes quite a thing. Now, if you give basically a really complicated assembly to a machinist, or lots of different parts to a machinist, the more tolerances you've got on there, the more complex the assembly, the higher the initial cost. So the higher the mold cost is going to be for a hooked rim. And I can completely understand why Zipp and Envy and these companies want to do hookless, because they're going to get a cheaper mold. But it is going to impact usability, and we'll come to that when we compare it against like the car rim thing, because, you know, this is not an F250, this is a road bike with skinny ass tyres. If you molded this inner section in one piece, because of the hook, you wouldn't be able to extract that part of the mold. So what they do, I believe, is they have these 2 thin plates, and then they put a spacer block in between those. So they insert this part into the mold, this part into the mold, and they knock this spacer block in to push those hook plates outwards, and those have the steel features that actually form the hooks. Then, when it's cured and everything's taken out, that center portion is taken out, and those hook plates can be pushed in and then removed. And if you actually look, and I'll drop in a clip here, if you actually look at a hooked rim, you can see a parting line. You can actually see this parting line witnessed on you know, a demolded carbon rim, and I'll try and put in some clips of that here, of that disc wheel that I just showed you. If we look at the disassembly procedure of the hookless wheel after it's been molded, so the top gets lifted off, then you start knocking out these center plates, and these center plates, there's 4 of them, or 4 or more, and they literally space those hook molding plates out. So once they've been removed, you then can take all these hook plates out, and then you've now got space to drop them down. Or we've got to take one more center plate out. Now the hook molding features can be moved down, and then they start to be able to be taken out. And throughout this process, obviously there's resin flashing everywhere, there's overflow, your hook is very fragile, so the yield, if there's voids or bubbles on the hook, that rim is scrapped. And these features are actually pretty small and quite hard to mold in. So the yield of this process is lower, the QC risk is higher because the hook is quite hard to form. And one other thing that, I mean, it's worth noting is there's so many parting lines on this mold that there's a lot of space for resin to flow into, and you get a lot of flashing. So you get a lot of resin going down these grooves, because none of these interlocking faces or mating faces in this mold are sealed with O-rings or anything. They're just metal on metal, so you will get resin flowing down these gaps, trying to kind of purge out from the gaps. And that really that's really not good, because when you get a pre-preg fabric, you are starting with something with a set volume fraction of fibers to epoxy, and that's set for the strength of the pre-preg. If you are losing epoxy out of that correct ratio, you're taking away from the final specification. You're taking away from the strength that pre-preg should be cured in. It's not like resin infusion where, you know, you start off with dry fabric and you pass the resin from one end to the other and everything gets soaked and you keep purging it through. With pre-preg, if you're losing resin, that means somewhere in your part afterwards it's going to be dry, or you haven't got enough resin as you should have had. Pre-pregs are normally formulated so there's a bit of excess resin to account for this. But with a mold like this, with so many parting lines, you get so much flashing that a lot of the resin will run out and there's more cleanup to do afterwards. So then you've taken out the bottom set of hook sections and now you can lift the mold out of the rim. But you can see how complex it all is. They do wear out every time you demold, and you mold the abrasive nature of the carbon. It's quite hard. It can damage the surface. You need to polish them, maybe even invest in new ones. And it's the same with frames. But when you've got a mold that messy with all those different parts, and this is a seriously simplified version, like I said, no dowels, no alignment features, no bolts, no pressure block for the nozzle to go in for the bladder. So if we quickly take a look at the cross section for the hookless version, it's so much simpler. You've got the outer plates, or the base and the top, and then you've just got the bit that goes in the rim bed, and that does the sidewall. There's no hook to worry about. There's no restriction, so you can pull that straight out. There'll probably be a tiny draft angle on the actual sidewall of the rim, so you can pull that out easily. There's very little chance of damaging the rim when you're pulling the center portion out. There's probably much better compaction around the sidewall because you haven't got the hook, and trying to mold solid carbon prepreg around that tiny hook and compacting it without any voids is pretty damn difficult. So I can see how this is better in production, 100%. It's simpler, probably stronger. There's probably a more unified compaction and better aligned layers of prepreg in the sidewall. But that's about where the pros for the hookless end. It's all in production. So, and when you come to demold, it's a lot simpler. You lift the top off and you take the center portions out, maybe 4, maybe 5, maybe even 3 if you can do it in 3. Pull those out and then you're finished. Your rim comes out. So it's a lot simpler to manufacture. The tolerance stack up is lower, and because there's way less parting lines, like I said, there's more a chance that your volume fraction of fibers to ratio is going to end being correct because you haven't got so much resin flowing down the parting lines. And this is so much simpler than creating an injection mold. Like pretty much anything made of composites or plastic is that's molded needs a tool. Now, if you're making plastic parts, I don't know, like a derailleur body, that's injection molded, and those molds are way more complex than pre-preg molds because you need to worry about how basically the whole part flows through orifices and tubes and entries and exits and bleeding ports and stuff, and we need to make sure the parting lines are in the right place. Whereas this is pretty simple because you're putting the thing in at the start, you're actually laying the prepreg in at the start of the molding process. The mold is quite simple, but the size of it, the accuracy of it, it can get expensive, and that's why they try to refine it. And if I was in a consulting company, engineering consulting company, there's definitely I would walk in and say, well, why is this molding so many pieces? Surely this can be simplified. And that's what they've done. But there are ramifications for the user, unfortunately. But those are the 2 bits of CAD. You can see it. The center portion on the hookless version, it just pulls straight out. There's nothing stopping it from, holding onto the rim, so it just pulls straight out. If it's easier to make and there's lower tolerance stack up, the machinist that makes the mold is going to give you a cheaper price. There's no ifs or buts about it.
SRAM has kind of admitted that there is a problem with hookless rims in some scenarios where the tyre pressure exceeds a certain limit or the riding conditions are not suitable for hookless. And they have proposed a method of gluing on or bonding on hooks onto hookless rims. Furthermore, I got a lot of hate once on a GCN video where I commented that hookless rims were all to do with saving production costs because you didn't have to extract quite a complicated mandrel in the carbon mold. Wow, that seemed really far-fetched, didn't it?
My F250 runs hookless, man. Like, it never ripped the tires off. Damn it. Right, well, the car tire's exactly the same, isn't it, you dumb fucks? Exactly the same. First of all, in bikes, we're still using essentially cross-ply tires, which is a technology only slightly less primitive than solid rubber tires or wooden cartwheels. And in cars, they're radial. They're completely different. The beads in our bike tires are floppy as shit because we want to be able to put them on with our thumbs, whereas a car you need basically a hydraulic press to mount a bead. Well, obviously the car tire has steel beads as well, and radial belts which roll over the top of the bead, over the top of the tread and under the tread to actually hold the structure. We don't have that in bikes, they're made of cotton and piss. The main difference with bikes, well, it's not the main, there's so many differences, I can't even believe I'm doing this. The car tire, the mounting section for the tubeless tire is offset from the center line, and it's not big enough, this is the crucial thing, it's not big enough to get both beads in at the same time. So obviously car tire is big, fat and strong and has steel running through it, both in the bead and across the top. And when you mount it, you push one bead down into this well here where it says drop center, and that's offset from the middle. And it's physically impossible to get both beads of the car tyre, because it's so stiff and wide, it's physically impossible to get both beads sat in there at the same time. Whereas on a bike rim, that is by design how you mount a tubeless before you blow it up. Both of them are sat in that well. The really critical safety thing here is that because our mounting well is in the middle and the tyres are floppy and, you know, ball bag material, we can put both beads in here at the same time and then the whole thing becomes loose. You can't do that on a car tyre, which is why a car tyre won't come off if you get a puncture. Well, not unless it's really drastic, because you can't physically compress this tyre together enough to make sure that both beads end up in the drop centre. It's just not possible. Now that drop centre is offset, so for a safety reason, if they were in the middle or if the drop centre was all across here, then yes, the car tyre could come off as well. One major difference. Obviously, there's other differences, like the sidewall height is a much higher distance than what we've got, a couple of millimeters or 10 mil or something on the bike. The tolerances, the tyres are tighter. Like I said, you've got steel belts running across the tyre as well as in the beads. And if we were prepared to take a hydraulic press out on the road with us in our back pocket to remount a tubeless, hookless tyre, I'd do it. But I want to be able to mount it with a pissy little plastic lever on my thumbs, and that's just physically impossible. This is why you have to take your car tyres to the garage where they've got the hydraulic press to demount and mount the things. So if we want to do it by hand, and if we want really lightweight, 250 gram tyres with folding beads, this doesn't work. If we had non-folding steel beaded tyres, let me think, like really cheap bike tyres that had really set diameter to plus or minus 1 millimeter, because this bead seat diameter is like 622 or 621.5, and that could be controlled to plus or minus 1 mil on the diameter, I wouldn't have any problems running hookless, tubeless. But our industry can't provide that because of the weight weenie thing. We want folding Kevlar beads, we want easy to mount, blow up with a CO2, and yeah, it just doesn't work. It's not possible to achieve that with a really floppy, skinny sidewall. And because we're riding cross-ply tyres, there's no real circumferential resistance to when you inflate it. So that bead does grow. And it's just a completely different operating window. So this whole car analogy thing is a load of BS. Let's quickly dive into the pros and cons, because there are probably many more, and I made this video in quite a hurry. The CAD took a bit longer than I thought, and I actually got quite involved with doing that CAD. Now I've got my own rim and steel mould if I wanted to make a carbon factory. Anyway, pros and cons for hooked: they work, they're safe, time has proven that. You can use high pressures if you want to. Now I'm going to get like the wide tyre, low pressure people coming and saying, oh, you don't need to run high pressures, but if you want to, you can. The tyre tolerance is not so important because you've got that extra little hook holding everything down. You can have these skinny ball bag tyres. And, with hooked rims, you can get tyres that you don't even, it's so easy to mount. So easy to mount. This is before we went to tubeless. So before tubeless came along and you went and bought a GP4000 non-tubeless tyre, so easy to mount with your thumbs. And it was never a problem with hooks. So you got tyre choice and you got the width versatility. So there's not these such high limits on what width you can run with what internal rims, because all internal rims are getting wider now. Now, cons, the mould cost is higher, there's more parts, tolerance stack up, volume fraction problem with the resin seeping out of the split lines again, and the layup becomes a bit more difficult around that hook because it's quite hard to get compaction and no voids and nicely folded over carbon in that hook. So all the cons, I would say, for the hooked versions are manufacturing, which is funny because all the pros for the hookless are the same. So if you look at this, the pros for the hookless are literally the same as the cons for the hook. So it is a manufacturing swap over. So pros for hookless: mold cost is lower, manufacturing yield probably goes up, less QC rejects, better compaction in the sidewall, the volume fraction of fibers to resin is probably better, and the layup is probably better compaction. And there's this, very wishy-washy claim that it's more aero, but quite frankly, I think that's bollocks. I think that's just like, oh, what can we say to excuse our manufacturing leaning? And the cons. Irony again, the cons are all the same as the pros for hooked. They don't work 100% safely. Now, you can shout at me like if you're trying to defend your Zipp 353 purchases, but they just don't. Go and look on the internet. When I say they don't work 100% safely, there's something called like safety factor, right? If you are straying over 73 psi because you've gone out and the tire's gone up to 75 psi because of the increase in temperature, that in my book isn't safe. Like, you can't be expected to monitor temperature change and look at, you know, the ideal gas laws whilst you're out on your riding. It's just, they just don't work 100% safely. There's no question about it. You've got the pressure limits, the tyre tolerance becomes extremely critical, and a lot of manufacturers can't make tyres that are within tolerance. Tyre choice is limited. I mean, we've got to a stage now where it's quite good that the tyre choice that you have is, you know, some of the best tyres out there. So Conti TR and Vittoria's, the Corsas. You've got the width limit things to worry about. I need to look up the table. Whereas, you know, on a hook rim, 1 minute I can be riding a skinny 25mm tyre, and then I can use that same rim for gravel on a massive tyre. But with the hookless ones, you can't. You need more of a specific wheel for each job, or a specific tyre for each job, and then they are difficult to mount. And this is going to be the rub. As these companies start getting more and more worried about lawsuits, they're just going to make them tighter. And even yesterday I was out in the cold and I didn't have any tyre levers, and I almost had to call someone to pick me up because I couldn't remount the Conti 5000 TR with my thumbs. And if I'd have just had a normal tyre that wasn't designed to work with hookless, probably could have been fine. That's my little analysis of hookless. I hope it puts a bit to bed about the manufacturing. If you want to see more of the CAD, let me know, and we could have put a bit more of that in, but I tried to keep it simple. Come on, Thomas de Gendt. Put that fucking pool noodle back in the pool. And this is the other thing. The team was saying they were using inserts to protect the riders. Like, well, hang on. Why don't we address the problem rather than trying to find a cure? Like, let's realise, if you're putting inserts in your tyres, we're taking away from the whole principle of tubeless. If you're putting a bloody foam pool noodle in there, the air volume inside the tyre is greatly reduced. Therefore, your likelihood of sealing a tubeless puncture is much reduced, because yes, you can have the same pressure, but the amount of air in there is going to be a lot lower because it's taken up by the pool noodle. So yeah, it's just crazy. Yeah, mountain biking use them to stop it, you know, really damaging the rim in rock impacts. But this on road, the inserts on road, I just don't get it. It's like, so if you do get a slight pinprick or a flat in the tyre, your pressure drop before it seals is going to happen super, super quickly because you've got less air volume. It's just absolutely crazy. How about do away with your pool noodle, go to your sponsor and say, look, we're not riding these rims, they're dangerous. We want to use a hook rim. But I can see why it's done in manufacturing, but the manufacturing consulting people, the engineering consulting team needs to actually look at the safety side of this, because it's, yes, you can lean out manufacturing, but when it crosses a line of safety, you need to take a step back and say, look, it's just not safe. You can disagree with me, but leave a comment down below if you disagree with me. See you later.